Wait, where's it? Two.
All right, this last portion of class is going to cover the FDC, things to consider regarding the FDC and setting up a series pumping operation. So the important thing is, you know, how these FDCs are rated. One concern was that we're going to break it. I mean, might, you know, but these FDCs are hydrostatically tested to 50 psi above the system demand pressure, or at least to a minimum of 200 psi. So, you know, if it has sprinklers, most likely it's going to recommend pumping it at 150. That's probably the minimum for the way these systems work. But so those would be hydrostatically 200. Anything else would be 50 above the system demand pressure. So, you know, if there's concern about, well, you overpumped it, you broke our system. Well, we pumped it within what you hydrostatically tested to. You know, so those numbers are important right there. The NFPA states the FDC should have an inlet for every 250 gallons per minute on the pump. And we did see that at the last building. It went to at 3 inlets. So, whereas, you know, most buildings will have 2 regardless if the pump capacity is 750 or 500. So here's a picture of an FDC. It's clappered inside there. Those clappers can become damaged or stuck or be stuffed with debris. So before you hook up, you're going to want to check those out. This picture is a remote or yard FDC, and those are more prone to break just because they're more exposed to the elements. There may be more corrosion inside. You know, there's pictures of people just pulling them up out of the ground because of all the corrosion happening. But they're tested every 5 years and are prone to failure. One method when hitting an FDC, our idea is to charge it early because they're prone to failure. If we charge it 50 below the system demand pressure, we allow the building's pump to work, but we're going to be able to provide it with pressure and a water supply should there be a failure and have uninterrupted water at that time. So by charging it 50 underneath the system demand pressure, we let the building do the work, and then we can seamlessly take over if we determine that we're pumping the building. When hooking up, if you hook up your first line, you're flowing, you'll probably have your other line hooked up before you're actually needed, but in the case that one's leaking, that's another use of a gate valve. You can screw it on while it's open and then shut the gate valve. So that's one way to overcome a damaged clapper in one of these FDCs. That makes sense? Yeah, the FDC supply procedures will be up to the jurisdiction and their policies and SOPs. Part of, and again, just to reiterate, the reason for this training is just to kind of give you some of the considerations to take into account when we're setting this up, so we can do it by the appropriate means. We allow the building pump, fire pump to work primarily. The building pump should be running at onset of sprinkler activation. The FDC can be charged with 50 psi below the demand pressure, and then with a significant flow inside, the residual could drop that's going into the building pump, and then at that point we may just automatically take over the building pump. FDC pumping considerations. You're either supplying the system or you're not. So if we're not meeting the system demand pressure on the discharge side of the system, the pumper is pumping into that check valve that we identified. No water is getting in, and we must meet or exceed that pressure inside the system to take over the pump in the system. Responsible for damage. Kind of already talked about that. So, that was a concern, that we learned about. Well, you overpump, you could break it. well, we should reasonably be able to over pump it at 50 above the system demand pressure and be well within the system's, safety limits. Dry hookup or charge, we talked about that too. The benefits of charging early would be seamless transition of water, and if that remote FDC is going to break, well, maybe it will break before we actually need it, and then we can go to a plan B, knowing that FDC is broken.
Can you describe some of the ways that people would know that it's broken?
Yeah, so if
What if it's broken underground?
we hook up immediately and we're under system demand pressure, or say we just initially charge it with 50 or 100 psi, that's well below the demand pressure, but water's leaking out, or we determine that we're pumping somewhere, I don't know where the water's going. It may be, and we'll talk about how to figure that out. That's an indication that you're pumping into a leaking FDC. And then a series pumping operation. FDC or NFPA 13E is very informative. There's a lot of answers in there and exactly how we should be using these systems. They recommend one pumper for every 150 psi of system demand pressure. And very tall buildings may easily be well above 250, 300, or even more. Being proficient in practice and setting this up will help streamline our operations and take out some of the guesswork or unknowns. It also provides redundancy in the case that a pumper were to fail while providing water inside. So, and then keeping the plan simple. We set it up every time. The last building we went to, we could have 100 psi from that hydrant outside. Say we do. We add 150 to it, because that's what we want to stay within, the margin of intake and discharge is 150. So that's 250 psi. That system demand is 265. So we create a little bit more. Maybe we've exceeded that just slightly, but we could probably get away with that. And they have a second FDC. We could set it up there. There's our redundancy. But in our older buildings that don't have two FDCs, it might be a good idea to set up that relay pump every time. That way you're rehearsed in doing it. And two, if our pump were to go out, the other truck can pump through us and provide that pressure. And it eases the work of both trucks. So, at 150 net pump discharge pressure, it's going to take 1400 RPM from that pumper. So then, it's going to be running for however long the fire is. Yeah, net pump discharge pressure. We just talked about that. And keeping the plan simple, those are important things to know of how to set it up, why we set it up like that, and when we should set it up like that. Those are important things to make those decisions. And this came from Port City Fire Training, I believe. One of their departments, this is how they set it up. So if you look at this, everything in yellow, up to floors 10, they have two standard pump pressures they're going to provide in a building. So if you did, 10 times 5 for elevation loss is 50 plus 100, 150. They're going to over pump a little bit by 70, right? Should be well within the safety margin because we have plus 50, right? But they've set this out real easy, take the guesswork out of it. We find out we're on scene of a 22-story building. All right, we're gonna pump that 275, and we're gonna set up a relay because, the system demand is a little higher. So, just another way to keep it simple, yet it takes into account, the safety margins above the FDC ratings and meeting that demand of the system. Series pumping. So we know estimating our system demand pressure. Through pre-planning, we can find that on the sprinkler test as churn pressure, and that's what the system is designed around, and that's when the fire pump kicks on and there's no water flowing. So that's the demand pressure the system is designed for. And usually when I do, if you do estimations on our buildings that are very close, So 5 PSI per floor, sometimes you can do 6. The 5 PSI is based on 10-foot floors. Commercial buildings and modern buildings are much more, so you can do 6. Times the amount of floors minus the first floor plus 100 PSI. So if we were doing pre-93, that would be 65 PSI, right? So, but for when we estimate it, we know we're going to operate with a 100 PSI, then pump our nozzle from the gauge at 90. So we're always going to use 100. But here's an example: a 32-story building, got 100 PSI plus 5 times 31 equals 255. Most single-stage centrifugal pumpers create 50 PSI at idle. Hydrant pressures can range anywhere from 40 to 80 normally, but like we've seen, you can have a lot more than that. So we've already talked about it. If we stay within that 150 PSI that we create, there's our safety margin. But there's arguments and reasons setting up the series pumping is beneficial, which we already talked about. And when to take over the building may be, up to the command. They may say take over the building because they see fire coming out the windows on a sprinkler building or a non-sprinkler building. Or we're gonna, if I'm a driver and I'm set up and I just barely charge the system, I'm gonna be listening to command and what fire tech's doing. If they're opening, they need another line on the fire floor, and then they're gonna want to send somebody up to the floor above to investigate, check for fire extension. They're going to need a hose up there too. So as hoses are opening and closing, that may be the key, that we're flowing major water in here, or we have the potential to at one time, so we want to take this building over. Alright, so I'm going to do just a little bit of those simple equations. And I have pictures in there, so that helps us follow along. But the estimated system demand pressure is 255. We just said the hydrant pressure is 55. So when we're setting this up to split between the pumpers, you would just take the system demand pressure, subtract the hydrant pressure, and then divide that by 2. So what that looks like is this: we got the hydrant pressure. So we figured out that 100 PSI is what each pumper should create, right? Because we took system demand, subtracted the hydrant, and whatever is left over, split that amongst the pumpers. 50 PSI is coming in at the hydrant. So this first supply pumper is receiving the hydrant pressure at 55. They're going to create 100, so their discharge pressure will be 155. The fire tech FDC pumper will have 155 coming in. They're going to add the same 100, and then we've balanced the load and met the system demand pressure. So I mean, that's good for keeping one truck from working super hard and keeping the efficiency of the pump. If we have 150 to this, we're at 205. So another 150, we should reasonably, with our pumps, be able to still provide 1,000 gallons a minute into that building. So if one of those were to go out, there's the redundancy built in there.
Now, is that taking the counting friction loss? If you're not pumping right at the building, you're pumping from a hydrant down the block or something like that?
Good point. So the FDC pumper will be in control, so they'll see what's coming in, and we'll get to determine. We'll get to how we determine if we're providing flow into the building. But yeah, friction loss could be a factor, but through 5-inch, we're only talking about 350 gallons, and then 650 gallons, and then 1,000 gallons a minute. It's short lengths, so it's probably going to be minimal in the 5-inch. But once we get to that 2.5-inch hose, then you're going to want to be listening to how many lines are flowing in the building, and then you can kind of count for that. So getting ahead of myself, on our pump card it says to start with our estimation of what we should pump the building at 150 plus 5 per floor. So they've already built in a little buffer zone in there to take into account friction loss for the hose and or you know, that buffer zone that's in the FDC. So it's already built in there.
You're immediately maxing out because you say that they're all pretty much 50. You can pump 50 into what their system demand pressure is. So you're already maxing out. By doing it that way, you're already maxing it out. So if you go up a little further, you run the risk of blowing the FTC.
Currently, it doesn't address if we're going to charge dry or charge wet on the system, I don't believe. You know, I believe that's a command decision currently. But, you know, so just one idea might be to pump below system demand. That way it's charged, the system's set up, you know, we know the pressures. And if we're 50 below what we know the building's creating, we're going to be pumping in that check valve. You know, if they start to outrun their water or they have a leak somewhere or something else happens, then maybe we take over seamlessly. So there's a lot of benefits into getting that system set up and pumping 50 below the demand right away, right? But
I'm just saying, once you add that 50 right out of the chute, you run the risk of maxing out.
Right. So that could be a part of it. So yeah, because ideally, if we provide system demand pressure, we have to know it's flowing inside, and then we'll split that amongst our 2.5 inch hoses. So, and that could be 350 gallons, you know, 600 gallons, 1,000 gallons. But that's where we start. And you know, once we take control, we could say pump at system demand or pump at system demand plus 50. But now we know the critical factors at play, so we know what to do when we're in that situation.
Good question.
Yes.
You got a building that's got four inlets. Are you connecting 2 pumpers, or are you connecting just 1 pumper to 4 inlets?
Yeah, that's a good question too. So if there's one FDC with 4 inlets, let's say no backup FDC, right? Like some of our new high-rises have 2 FDCs. You know, that's kind of a different ballgame. But if there's 4 inlets, say you started with 2, I mean, and you have to develop a high pressure, you've already set up that relay system. So, you know, otherwise you could set up another relay system into the same one.
I'm just saying, are you having 4 lines come off of 1 truck to one? Are you?
If there's that many inlets, it might be a good idea. Yeah, if you're trying to build redundancy to, you know, then you would just hook up one other fire tech pumper, and you could lay a line from this pumper to another truck, and they could feed it. So that way, I mean, you're working in series, right, for one truck. So it's just, yeah. And then if this one goes down, you just gotta make it up somewhere. You both make it up, right? But yeah, that answers your question. The other thing on here is we haven't talked about pressure governors, right? But we set our pressure, and then depending on what we're flowing, what we have coming in, residual, the engine keeps it at a constant pressure, right? The pressure governor. So as lines open up and close inside, you know, it could be 1 line, 2 lines. We don't want these 2 pressure governors feeding pressure signals back and forth, right? So as water shuts down and our residual may build, this truck, if it's also in pressure mode, will go up and down. So when people set up rural water relays, the last one in line is always in pressure mode. If you're supplying another pumper or a ladder truck, you should be in RPM mode and watch your intake and discharge. That way, you don't have pressure governors. They call it RPM hunting. You know, and Vern said he kind of heard some of that when we were doing that. But if you're supplying another truck, once you get where you're at, you go in RPM mode, and then you just kind of have to watch it and listen to your engine. Kind of sum this up just through our talk is that, you know, we know about the hydrostatic tests of the FTC, 50 above the system demand. There's a margin of protection there. Friction loss based on the estimated flow inside the building. We talked about that as well. added in after to ensure the fire department pumper is supplying the correct water to the building. And a generalized approach, plain and simple, right? So sometimes, these factors matter, but if we have, it's kind of like with the 2.5-inch hose. Yeah, we could get away with 2-inch hose on some buildings. Some buildings we won't, but we carry 2.5 all the time because we know that it's one weapon to carry to all of our buildings. So that's why I kind of recommend standardizing our approach, practicing it, and being proficient in that. Intake relief valves. Eliminate the math. Have the hydrant pumper give us up to the intake relief valve. So on the pumper, we know ours is 125. So that could be a limiting factor for us, or we know that. Instead of doing the math, you can tell Brentwood come to us, lay your supply line from us to the hydrant, and then you hook into the hydrant and send me 125. So then that 125 coming in to us, if we add 150 to that, we can provide 275.
Which will cover almost all of our buildings.
Yeah, as they get taller, it gets more complicated. You gotta start thinking about 3-inch hose or high pressure 3-inch hose. Yeah, in high PSI pumping operations, high pressure hose, 3-inch hose is in a capped intake relief valve may be required on those high pumping operations. We don't have the ability to cap our intake relief valve. Example 2, got a 41-story building. Again, 100 PSI plus 5 PSI times the number of floors, 100 plus 200, 300 PSI. System demand pressure. So if we have 50 coming in the hydrant, do that math. 300 minus 50 divided by 2. Again, we end up with each pumper needs to create 125. So this pumper creates 125 and sends out 175, intake of 175, and then you get your 300 PSI. Like I said, standardized approach. Send us 125. Send us 100. Send us 125. Yeah, series pumping. It's a high pressure operation. You want to verify if the FDC is is supplying the building. So when the FDC is charged, take note of the intake and discharge pressures, and then you can gate down your 2.5 discharges. If you have 2 open, you're going to need to do them both. And a reduction in the discharge pressure and increase in residual would let you know there's water moving through your truck. Does that make sense? You guys that haven't pumped very much, does that make sense? So, right, as we push more out, we're going to be pulling from what's coming in, kind of. So our residual will come down. That's one way you can find out that you're pumping, you're providing the system. Once you notice that, and if command doesn't know, like say we start 50 below and we notice that, we'll let command know it may be the sign to take over the building at the correct pressure.
And if anybody's trying to gate down the pumper with the current controls, it's difficult to gate it down scientifically. It's, you go down 10, 15 PSI, just one little square, and it's challenging to keep it where you want it.
Right. Well, and that's always assuming something's flowing. If it's flowing in a check valve, you may not have any changes. But the other thing is, on our next pumper, maybe we think about getting some flow meters on some of our 2.5 discharges. It takes even more of the
regular handles,
the questions out, regular handles and flow meters. So that will help us, test our equipment, but also let us know, oh, we're flowing in the building. So if pumping into the check valve or not overtaking the system, pumpers must discharge at least 100 gallons a minute. So you can do that a number of ways. You can open the booster line or hook up another discharge, crack a discharge somewhere. But just like any pump, you're going to want water moving through that pump if you're not moving water. And then plan B. So in this picture, series pumping can be a high pressure incident, so they'll sometimes tie these hoses off and to the FDCs or to the pumper in case they were to break near the coupling, because that would be a likely place they'll break. and they could whip across. So, it's a common practice to tie these down when you're doing a high pumping operation. First plan B is to pump to FDC, right? Because we let the building work. The next one will be pumping a test header or a first floor standpipe valve. And I think we've, shown when we can do that, when we may not do that. And be proactive. So once you get that series pumping set up, take a walk around, look at your first floor standpipe valve, take a look at your test header, and maybe try to identify where that valve is inside, or whoever's down there, that hopefully they can identify that. Or a vertical standpipe, which we'll probably need 3-inch hose to do that realistically if we're going to provide our own standpipe up into a building. So if we got catastrophic failure down there right before the risers, and there's 2 risers, or a failure in 1 riser, and that's all we got, there's not going to be an easy way to get water back up there. We could use a ladder truck, to get us as high as we can, and you could stretch hose up or unshoulder hose down as you're coming down. And we're always going to use the elevators while they're in service. It all depends on the location of the problem. So, hopefully I try to, say the critical parts of the pump room and identify those. So, if a problem occurs, the reasonable solution is going to be determined based on where that problem is. And that's all that says. So if you're pumping a test header, more accessible than the first floor riser, most times you'll have to use less hose. Captain Newkirk asked a question earlier about the distance of pumping and friction loss. So we at least need to be close enough to that FDC that we're only using 100 feet of hose. And FDCs are tested annually when they do the fire pump test, so this should be reliable. But we must pre-plan, make sure we can identify those valves and know how to shut those off and adapt as needed. First floor standpipe valves cannot be a PRV, maybe a much longer delay to hook into those, and you may need a Siamese to hook up to that, or double females, and you may have limited flows hooking up that way. An exterior vertical standpipe, this could be basically outside the building like you see here, or inside in a stairwell. And yeah, so they have hose here and it's tied off, they're flowing off the roof. You need probably 3-inch hose for that, just due to the friction loss. You're going to need 3-inch hose. There's some math, there's some math up there, and at this point it's only support for hose lines. 2.5 will quickly be limited on service test pressure, so you need 3-inch hose and sprinkler support. Must tie off every 100 foot with webbing below the coupling. It helps redistribute the weight off the coupling so it doesn't break. The supplies you would need, like I said, 3-inch hose, rope, Denver pack hose bundles, and our normal operating fire pack line. All right, lesson summary. We talked about sprinklers, their functions, layout, valve locations, how to isolate them, shut them off, and then drain them through the system. Standpipes, talked about the different classes, dry and wet, our riser controls. We may have hose cabinets or have these valves in the stairwell, and then we just talked about the FDC fire pump room and setting up our series operations. I believe that's all I have, so is there any questions? Anybody have any questions? All right, thank you.
Real good, Tom, real good.
Pizza party.
Oh, Tom's buying pizza?
Tom's buying pizza.